Let me show you how I analyzed the data from this dissociative identity disorder study using the build test model feature in the OOM software. Now recall in the study, the independent variable was comprised of 4 groups, as you can see on the screen here. And the dependent variable, or the outcome variable, was the number of words correctly recognized, and that could range from 0 to 15 as whole numbers. Now here in the software, we can see the 94 cases or individuals. We can see the orderings arranged as columns here. Let's go ahead and select this Define Orderings button here so we can open up that window. I'm going to go ahead and maximize it. 2 orderings we're interested in here are the grouping ordering and the recognition ordering. So with the grouping ordering, we can see 1 is set up for the DID patients, 2 controls, 3 simulators, 4 guessers. I can take a look at the distribution here and see I've got 19 DID patients and I have 25 individuals in the other groups. Again, we have all 94 people here and the 4 units of observation. Now we take a look at the recognition ordering, and it is set up as 0 to 15, again as whole numbers. I can see the distribution here for all 94 individuals again. And again, we have 16 units of observation here, 0 through 15. So I can go ahead and select OK or cancel here now that I see how the data have been set up or the orderings have been defined. Now let's go ahead and run the analysis. So I'll select Analyses, Build Test Model. You can see I've already been here before. Let me go ahead and just clear this out though. And so we can move the grouping ordering over. I can just select it and double click it, or I can select it and hit include. Then I need to connect it to the outcome ordering here, recognition. Again, orderings in the OOM software, just another name for variables. So the group is considered as the cause, typically the first ordering that you put in the model. Then you link that to the effect. In this case, it's the recognition ordering. So now I've got the randomization test selected here. I've got 5,000 trials set up, and I'm using default options everywhere else. The default for the randomization test is conforming observations. We're going to randomize according to those conforming observations. And then I can go ahead and select OK to run the analysis. So it's iterating through here. And we're taking the text output window, and we see the analysis that we've run here. We see the various options we've chosen, the ordering frequency summaries. So again, we've got 4 units for the grouping, 16 for the recognition. Do I have any missing values and so forth? Here is the model that we're testing, group to recognition. And here we get the classification result. So we had 94 classifiable observations. 70 of those were correctly classified. So we turn that into a percentage, 70 out of 94. We get 74.47%. So that as our percent correct classifications index. It seems fairly high. We can go to the multigram to see what's going on here. So I just went to that window. Again, notice it's here, or I can select it by using the tab here. And so we see the multigram with the Bayesian-like classifier doing its work. The green bars correctly classified observations, red bars incorrectly classified. I can right-click here to get the counts. So now here I have the number of individuals per frequency bar. I think in the other video, I think I put lines around the bars. This is just for aesthetic purposes if you want to change the nature of the multigram or the visual presentation of it. And we can see the PCC again reported here, the 74.47%. And we see the controls recognized correctly more words than the other 3 groups or individuals in the other 3 groups. And we see some differences there between these groups as well. Now in the video, the other video, I also showed a colorless multigram. So to remove the colors, if you just want to look at the data without the Bayesian classifier results, again, I right-click on the graph and I can change the multigram colors and just choose whatever colors you want. I think I used silver in the other video. I'm just going to scroll up for that. And there it is, and select OK. And there you have it. So now you have a colorless multigram. You can just present the data without the results of the Bayesian-like classifier. And you can save or export these graphs in various formats and edit them if you wish. Now let's go back to the text output window. Again, I could select the window here or just go to the tab here. And let's take a look at the randomization test. There is the PCC again reported again here, the randomization results. There's the PCC reported again, 5,000 trials. Here are the minimum and maximum values for the PCCs from the randomized versions of the data. Not one time did I find a PCC of 74.47% or higher. So that means our chance value is less than 0.0002. And so that's a very low chance value. That would lead us then to rule out physical chance as an explanation for the pattern that we're seeing in the data. And we move on then to a causal interpretation of what we see in the multigram. Again, I can turn the colors back on here if I wish. Now for the specific comparisons, I go back to the data edit window, and let's say I want to compare the DID and simulator groups. Now I could go ahead and edit this ordering here by just deleting the other two groups, but if I want to come back to an analysis with these four groups later, perhaps I don't want to fiddle with this ordering as it's defined. So instead what I'm going to do is select Edit and then Copy Delete Ordering. And I want that grouping ordering. I'm going to paste it into this data set. It's the only data set that's open. Select OK. So notice now here it is just duplicated. So now I'm going to go back to the Define Orderings window. And here it is, group. Now we can relabel it here. And so maybe we'll make it group. We'll go D versus S for simulators. And you can put a description here if you wish as well. Okay, and now let's go ahead and get rid of the controls. So I'm going to just delete them and get rid of the guessers and delete them. Let's go to the distribution, and we can see I've got the 19 DID versus the 25 simulators. The other individuals now are not going to be recognized by the analysis because, as you can see here, they are uncategorized observations, those 50 individuals. So I've got my new ordering defined here. I'll select OK to save the results. Here I can see my new label for the ordering. So now let's just go to the analyses and build test model. I'm going to clear this out, put in my new cause ordering and put it to the recognition. Again, I'm just double clicking to move it over. Same options will work here, so I'll select OK. It's going to iterate through. And taking the text output window, again, here are all the options that we've chosen. We get the ordering frequency summaries, and here we see the model that we are testing. And there are 44 individuals to be classified. 33 of those were correctly classified. Turn that into a percentage, 33 out of 44, and you get your percent correct classifications index. And 75%, again, seems like a respectably high result. We can look at the randomization results here. And there's the PCC just repeated again. There are the 5,000 trials. There are the minimum max values. We have 171 out of 5,000 trials that were 75% or higher. So that gives us a chance value of 0.03. Still a fairly low value, not as impressive as we saw before, but this might lead us then to rule out physical chance as a potential explanation for the pattern that we're going to see in our data in just a moment. Now, I don't recommend any sort of cut point with the OOM software for your chance value, for example, 0.05 or less. Just report the chance value out to so many decimal places and then provide your interpretation of the data. So let's say here we're going to rule out physical chance. So that means we then need to move to a causal explanation of the data. Now I'm going to go back to the graphics output window. I can see it here in the background, or I could select the tab here. And now I need to use this pull down menu or the double-headed arrows here. And there is our new multigram. So we have the DIDs versus the simulators. I'm going to right click and just turn on the counts. I always find that fairly handy. And we can see what's going on here. We see some general separation between the two distributions. It looks like the simulators are mainly between 0 and 2 recognized correctly words. The DID are a little bit higher than that, typically 3 to 7 correctly recognized words. So it looks like the simulators are perhaps overdoing it in terms of the interidentity amnesia. So recall the purpose of the study was to see if one personality could recognize what was remembered by another personality for the individuals who have been diagnosed with DID. It looks like the simulators are sort of overdoing it with regard to the amnesia between the two personalities compared to the actual DID individuals. So we can see the general separation here. We see the green bars and the 75% for the PCC. Now we do see 2 individuals here recalling 5 words who are correctly classified as simulators, so that sort of bucks the trend. So the idea that all of the simulators are overdoing it with regard to the interidentity amnesia is not true. It's not true for everyone, but it seems to be true for most of the individuals comparing the simulators to the DID individuals. Now, if we had other orderings in the data set, we might try to run some additional more complex analyses to disentangle this a little bit further to see why these particular simulators are matching up better with the DID patients than these other simulators. So this is how we would go about running these individual or pairwise types of comparisons. So if I wanted to compare two other groups, again, I could go back to my define orderings window. I could work with this ordering and redefine everything, or I could copy the group ordering again and delete two of the four groups, and then just work systematically through all pairwise comparisons. But that's all there is to the analysis then. I suppose one final thing, if you want to report descriptive statistics just for the sake of doing so, you could select analyses and descriptive statistics, and you could move over the recognition as the ordering, and you can divide that out by the groups, and you can get medians, means, modes, whatever you want here for the different groups, standard deviations perhaps. Select OK. And then there you see the descriptive stats you could report in a table. But for my money, the most important thing to report in this paper would be the colorless multigram and then the multigrams with the Bayesian-like classifiers for the specific comparisons that you're interested in examining. And by the way, in closing here, in the original study, the authors concluded that the DID patients were not significantly different from the simulators. But here in the OOM analysis, we're seeing some differences that are potentially interesting or theoretically interesting that we should explore further.